Ask your friends to log in. Ravindra, here's Mekala, Subun, Subun is there. Uh, Satish Paul is not there.
Good afternoon, sir.
Okay. Ask your friends to join. Are you tracking the problems?
Yes, sir.
Okay, I will start. Uh, I will not go directly to the plane stress problem. I'll start with the simple biaxial stress condition. Okay. The problem statement is like this. You will give generally, you will give the sketch. Is subjected to normal force sigma x of magnitude 500 Newton per mm square, sigma x, sigma y, sigma y, and sigma y is of magnitude 300 MPa, 20 Newton per mm square, and he has asked to find the stresses on this plane, which is at an angle of 30 degree, 30 degree, okay, when measured from the vertical in the anticlockwise sense. So this is a problem. You have said that calculate the normal stress sigma n equal to how much? Tangential stress sigma t is equal to how much? Resultant stress sigma r how much? Uh, Obliquity. Discuss. See obliquity in the sense. Let me. If I take a plane like this is normal stress. This is the normal plane along which normal stress is acting. This is a tangential plane along with tangential stress is acting. If I take, if I find the resultant of this normal and tangential stress, this is the assume that this is the resultant. Assume this that this is the resultant of normal and tangential stress, which is making an angle pi. Let me represent it properly. This is the resultant. This is the This is the resultant, which is making angle pi. Okay, to complete the, if I resolve this is sigma normal. This is as usual sigma t. I can write tan pi is equal to sigma t by sigma r, or pi is equal to tan inverse sigma t by sigma r. The angle made by the resultant with the normal is called as angle of obliquity. The angle made by the resultant with the normal is called as angle of obliquity. Okay, it is given by ratio of sigma t by sigma 1, tan inverse sigma t by sigma. So tan inverse sigma t by, sorry, I made a mistake. Sigma t by sigma n. Sigma t by, sorry, sigma t by sigma n. Opposite by adjacent. Sigma t by sigma n. This is called as angle of obliquity. Okay, resultant in the sense, resultant of resultant of r square is equal to sigma t square plus sigma n square, or r is equal to root of sigma t square plus sigma n square is the resultant. Okay, and he has asked angle of obliquity. These are the given problem. First, as usual, sigma normal. Can anybody tell me, just by looking into the formulas which you have derived in the previous classes? Let me open that, you will come to know. You can see here for biaxial stress condition, sigma n is given by sigma x plus y by 2, this is sigma n, sigma x plus y by 2, sigma x minus y by 2 cos 2 theta, and then sigma t is given by minus sigma x minus y by 2 into sin 2 theta. Okay, let me write sigma n first. First unknown, sigma n, which is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 into cos 2 theta, which is equal to sigma x is 500 plus 300 by 2 plus 500 minus 300 by 2. Always I told you, top down. From the top of the plane, you should draw a vertical. Top down. Sweep the clock, sweep the 6 p.m. clock or 6 p.m. clock towards the hypotenuse. If the sweeping is anti-clockwise direction, my theta is positive 30. In the since theta is counterclockwise direction, my theta is positive. Okay, then this will be equal to cos 60, or which is equal to 400 plus 100 into cos 60. Can you tell me what is sigma n? What is sigma n?
450.
450. What is the unit? What is the unit?
Newton per mm square.
Or MPa. 450 Newton per mm square. This is sigma n. sigma t is given by which is equal to minus of sigma x minus sigma y by 2 into sin 2 theta which is equal to sigma t which is equal to minus of sigma x. It's 500 shall I write directly 500 minus 300 by 2 into sin 60 sigma t which is equal to 500 minus 300 minus 100 sin 60. How much will be this?
Minus 86.60.
Minus 86.6 Newton per mm square. We have found sigma n, sigma t. We should find sigma r. Sigma r, sigma r, which is equal to root of sigma n square plus sigma t square is equal to root of 450 square 450 square plus minus of 86.6 the whole square or sigma r is equal to how much?
441.58.
Properly?
441.58.
Innocent ನೋಡಿ innocent
458.25.
458. Why you do mistakes? Simple calculation I don't understand Raghavendra. ಏನಿದೆ ಅದರಲ್ಲಿ calculator is calculating that why you make mistakes 458.26 MPa. Okay, next uh, let us find sigma 1. So in this equation if I go back here, you can see my uh, sigma n is maximum when theta, this is the equation. I cannot directly say when the cos 2 theta is equal to 0, this will be maximum. I have to differentiate this one. When I differentiate this one, I will be left out minus sigma x minus sigma y by 2 sin t 2 theta is equal to 0. This term, the verify the share, this thing, sigma x minus sigma y by 2 minus sin 2 theta. Okay, then this will be equal to 0 only when theta p1 is equal to 0. 90 degree apart will be theta 2 theta p2. Therefore this will be theta p1 is equal to 0 and theta p2 is equal to 90 degree. We have discussed that directly. You cannot substitute cos 2 theta is equal to 0. The angles are theta p1 principal stress p1 is 0 degree and the other will be 90 degree. There is no need to do this also. When I do that, I will be getting sigma 1 as sigma x and sigma 2 as sigma y. Okay, then the principal stresses are, therefore the principal stresses are sigma 1 which is equal to sigma x which is equal to 500 Newton per mm square, sigma 2 which is equal to sigma y which is equal to 300 Newton per mm square. Okay, obviously theta 1 theta p1 will be equal to z0 degree, theta p2 which is equal to theta p1 plus 90 which is equal to 90 degree. But you should always remember this: when there is a biaxial state of stress, This plane itself, which is at 0 degree, there is no shear stress on this plane. This plane at 0 degree itself is the principal stress. This is the x plane, and this is the y plane. 90 degree to that is a low. This is the plane which we are talking. If I take a body, this is the point. This is the state of stress at this point. And that point, how do you define the plane is by the normal. This x-axis, this is the normal. For this point, when I pass a plane, the normal is the x-axis. So x-axis there is no shear stress. This itself is my principal plane. 90 degree apart. This plane itself is my principal plane. Okay. So sigma 1, sigma 2 are 500 and 300 Newton per mm square. That's why I will not ask in the examination. It thinks that students know that sigma 1, sigma 2 are sigma x and sigma y only. Why need to ask? But still students don't know that sigma x and sigma y is equal to sigma 1 and sigma 2. Okay. So this is sigma 1 and sigma 2. Now in order to calculate uh, the maximum shear angle, the maximum implied shear angle, this will be maximum sigma 2, which is equal to sigma t, which is equal to minus of sigma x minus sigma y by 2 sine 2 theta. This will be maximum when 2 theta is equal to 90 degree, or theta s1 is equal to 45 degree. I will check, I will get 2 theta s if I write theta s1 is equal to 45 degree, or you can write theta s2, will be 45 plus 90. Okay. Or you can also follow my method. You can also follow my method. Uh, what you can do, when theta p1 is 0 degree, when theta p1 is 0 degree, it is neither plus or minus. Okay, 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 okay. See, here I'll come back to here. Sigma x minus sigma y, which is equal to 500 minus 300, and still theta 1, this itself indicates sigma p, theta p1. There is no this one ambiguity, and theta p2 is 90 degree. Then theta p2 is this has to be okay. I'll follow the same convention, nothing to worry. You can do like that also. Theta p, theta s and theta p are 45 degree apart, since are assuming theta s as assuming theta p1 as positive, theta s1 is equal to theta p1 minus 45 degree. Therefore theta s1 is equal to minus 45 degree. Theta s2 is equal to theta s1 plus 90 degree. Therefore theta s2, which is equal to minus 45 plus 90, which is equal to 45 degree. Theta s2 is 45 degree. Okay, we have found it a magnitude. It remains the same, theta s1 and theta s2. Nothing will change. Since sigma t magnitude we have found, if we have not found sigma t, which is equal to minus of sigma x minus sigma y, 500 minus 300 by 2 by sine 60, which is equal to minus 100 sine 60, which is equal to minus 86.6. We have found it right. We have found it right, which is equal to minus 86.6 Newton per mm square. Since Since this sigma t is with negative sign, it rotates the S1 phase in clockwise direction. Since sigma t is negative, it rotates the S1 phase in clockwise direction. We have stick on to our convention and we have solved the problem. Okay. Now let us plot. Let us plot the sketch. First we have to write the xy axis. XY axis. X, Y. Theta P1 is at an angle 0 degree. Theta P1 is 0. Theta P2 is 90 degree. I will indicate plane P1. Plane P2 is at 90 degree to this. Plane P2. Indicate a plane like this. And then sigma 1 is equal to sigma x, which is equal to 500. Sigma 1, which is equal to 500, which is equal to sigma x. Sigma 1 is equal to 500, which is equal to sigma 2, which is equal to 300. Sigma 2, which is equal to 300. So this is about our principal planes. Also, I forgot to tell you, these planes of maximum shear stress are also accompanied with average stress. In order to calculate that average stress, we need to substitute in sigma expression the maximum shear theta s1 or theta s2. Okay. To find sigma average, substitute theta s1 or theta s2 in sigma n. Therefore, sigma n, which is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2 cos 2, I'm substituting s1 2 theta s1, or sigma n which is equal to for theta s1 which is equal to 45 degree. This 45 degree, theta s1 is equal to 45 degree. Check once. Magnitude of shear stress. Yes. Okay. For theta s1 is equal to 45 degree. Sigma n which is equal to cos 90 is 0. Therefore, sigma x plus sigma y by 2. Okay. And then cos 270 will be minus 1. That will be minus of minus. Then it will be equal to uh, cos 2 into how much 2 theta s1 180, right? 180 minus 1. Sorry. Theta s1, theta s2 is 45 degree. Okay. Theta s1 is plus 45, theta s2 minus 45, which is nothing but cos of minus 90 is also 0. Uh, Cos 90 is also 0. Give me a moment. minus sigma 1 by 2 plus sigma plus sigma 1 by 2 cos 2 theta is 1 and 2 theta. Okay, give me a moment, sorry. So this is one and the same. So one and the same. Since I have used this, the method which I have followed for plane stress condition, I am following the same. It doesn't. Uh, we should not deviate. Sigma x plus y by 2 cos 2 theta 1 obviously cos 2 theta plus or minus 1 that will be 0 only. Okay, for theta s1 is theta s1 is 45 degree, sigma is equal to sigma x plus y by 2, or for theta theta s2 is equal to minus 45 degree, theta h2 is equal to plus 45 degree, then also sigma n is equal to sigma x plus sigma y by 2. We left with the same. This sigma n will not change, its magnitude remains the same and sign also remains the same whether you substitute plus 45 or minus 45. Now let me represent this. Explain by plane. Theta s1 is at an angle minus 45 degree. This is it is at an angle minus 45 degree. S1 theta s1 s1 plane s1 plane. Reset that mouse pointer, it is getting clicked. Time being you adjust, okay, and then theta s2 is 90 degree to that, 90 degree to that. So okay, this is something, this will be s2 s2 plane. This is one second theta from this one you should measure theta s2, total difference is minus of 45 minus of minus 45 90 degree. Okay, now if I represent this, let us represent the plane. On which sigma t minus 86.6, since this is in clockwise direction when negative sign, it will rotate the body in clockwise direction. I should write minus 86 point, this is clockwise direction, this will like this, s1 phase 86.6, and opposite to this it will like this, and also accompanied with average stress which is equal to 300 plus 500 which is equal to 400 MPa. Let me write average stress sigma average is equal to 400 on all bases. Average. Okay. Have you understood this? There is no need for representation in case if you have biaxial state of condition. Principal stress remains the same. At planes is 0 and 90 degree, and then shear planes at an angle 45 degree, and at an angle of minus 45 degree, and at an angle of 45 degree. Okay. We have derived 45 degree and 135 degree, right? It's one and the same. If you see, if let us see how this has come. The should be same. The stress orientations should be the same. Yes, see, same. Okay, same. Since sigma x minus sigma y was positive, I'll send you one more link. Within 2 minutes, I'll send you one only. Last 10 minutes remaining. See this phase, this has been inclined at plus 45 degree. Okay, and it is rotating my S1 phase in clockwise direction. You can see, and this is my S1 phase. It is rotating S1 phase in 45 degree. It remains the same. No need to worry. Okay. Have you understood this? Follow this convention. There's no need to worry. This is the standard problem. We can solve like this. First, we need to find the angle, whether it's positive or negative. Find the normal stress, resultant stress, angle of obliquity, and then we'll go on to find the principal stresses. Shear stresses, we need to, I can directly substitute from the formula, or I can do from the convention what we have found. Shear plane and principal planes are 45 degree apart. If I substitute this, since my principal, if theta p1 is 0, there's some value could have been done easily. Since theta p1 is 0, or I can use formula also. Since theta p1 is 0, I have assumed that's positive, and then theta p1 minus 45 will be my theta s2. 90 degree, 45 degree, 90 degree apart will be theta s2, and I have added that and I find the magnitude. Since sigma 2 is with negative sign, it rotates the s1 phase in clockwise direction. This is how we have represented. Okay, one more problem will solve. The principal stress at a point in a bar, or let me write the sketch. Find the same. Now you have to tell me what is theta. Uh, this is for you. Those who understood the same convention will tell me. This is sigma x, which is equal to 200, 200 sigma y 100, 100. This is at an angle 30 degree. This is at an angle 30 degree, and this is at an angle 30 degree. Okay. What would be this angle? What will be this angle? When this is 30 degree, what will be this angle? Isn't it? If you drop, if you drop uh, a vertical like this, if you drop a vertical like this,
60, sir.
no, wait, if you drop a vertical like this, obviously uh, this angle I have given with respect to, sorry, this angle I should have been shown like this. This angle is with respect to whatever this I have written is with respect to vertical. This angle is with respect to vertical, 30 degree. So I can write, I can write. This is with respect to vertical, 30 degree. Therefore, from alternate angles, this angle should be also equal to 30 degree. Okay, this is like this. With respect to vertical, this is 30 degree. Therefore, this angle will also be 30 degree. Okay, we will follow the same convention. Same convention. Top down, sweep the clock. Top down, sweep the clock. I am coming from the top. I am sweeping the clock. Since my shaping is anti-clockwise direction, my theta is equal to 30 degree, counterclockwise positive. Okay. He has given, you can see in the, I cannot clearly write the sketch. He has given this angle with respect to this, not with respect to horizontal, with respect to vertical. That he has to explicitly give, but in unfortunately, he has not given like that. With respect to vertical is 30 degree. Okay. Next, this is the given problem. This is the given problem. We need to find sigma n, sigma t, sigma r, phi, sigma 1, sigma 2, theta p1, theta p2, sigma t max, sigma t min, theta s1, and theta s2 represented in the sketch. The same formulas I will use. Sigma n, which is equal to sigma x plus sigma y by 2 plus sigma x minus sigma y by 2. I'm left with 3 minutes. Within 5 minutes, I'll send you one more look. Sigma x minus sigma y by 2 cos 2 theta, sigma n, which is equal to 200 plus 200. It is compression minus 100. Sigma x is equal to 200 along positive x-axis. Sigma y is along negative y-axis minus 100 Newton per mm square. Newton per mm square plus 200 plus 100 by 2 cos 60. Therefore, sigma n, which is equal to 50 plus 150 cos 60. Can tell me what is sigma n?
125, sir.
125, 125 MPa.
Newton per mm square.
Sigma t, which is equal to minus of sigma x minus sigma y by 2 sin 2 theta, okay, which is equal to minus of 200 minus 100 by 2 sin 60, which is equal to, we calculate it. Meanwhile, I will be sending the second link. Join immediately.
Minus 43.30.
Check properly. Minus sigma x minus of sigma y, that will be plus 100. Why? Sorry, minus of sigma x minus sigma y. This is plus 100. Plus 100. Tell me the magnitude. Minus 130.
Minus 129.90.
129.9 Newton per mm square. Okay. I will stop at this point. Within 5-10 minutes, I will sending you the second link. Okay. I request everybody to engage. Nice students. Okay. Thanks.